I'm thrilled to announce the completion of a book, and I encourage viewers to stay tuned until the end for more details. The topic at hand is the concept of time, a recurring theme on this channel. We've explored how black holes warp space, leading to time dilation, and delved into the effects of gravity on time. The James Webb Telescope's ability to peer into the distant past by leveraging the fixed speed of light has also been discussed. Despite these insights, the nature of time remains elusive, prompting a deeper exploration. Host Alex McColgan introduces a collaborative effort with his brother, presenting a model that aims to offer a fresh perspective on the mysterious phenomenon of time. The foundation of this model rests on the idea that time is not just a measure, but another dimension, akin to the three dimensions of space. Before delving into the fourth dimension, the video takes a moment to ensure viewers understand the basics of three-dimensional space: height, width, and depth, all of which form right angles to each other. The journey continues by imagining two-dimensional, 2D, and one-dimensional, 1D spaces, each with limited movement possibilities. The transition from 1D to 2D to 3D involves adding dimensions perpendicular to existing ones. The challenge arises when contemplating a fourth dimension, as drawing a line perpendicular to three others proves challenging within our familiar 3D space. The narrative then seamlessly introduces the concept of time as the fourth dimension. Einstein's theories of relativity, connecting space and time into a unified spacetime, align with this idea. The video emphasizes the essential role of time in allowing movement within three-dimensional space. To aid comprehension, the video proposes a model where 3D reality is compressed into a two-dimensional plane, with the X and Y directions representing space and the Z direction representing time. This perspective allows for a unique exploration of the relationship between motion in space and its impact on the flow of time. The model suggests that, akin to our inability to see additional spatial dimensions, we cannot directly observe time. However, the video explains the implications of motion in space on the experience of time. Drawing on Einstein's theory, it proposes that the faster one moves through space, the slower they move through time. This relationship is depicted through vectors, highlighting the trade-off between spatial and temporal motion. The video cleverly employs stick figures in a 2D space to illustrate the effects of high-speed travel on the perception of time. It introduces the concept of time dilation, where an observer moving at high speeds experiences time differently than a stationary observer. This leads to the intriguing idea that, from the perspective of the traveler, the universe warps while they remain unchanged. The video concludes by reflecting on the implications of viewing time as a direction.